So we'll start with the wind turbine blade fabrication process. So like the design was done by a senior Atreya, as you already know. But basically the major problems with this is that we are making a composite two-part blade. So we'll come to the details later. But this main presentation is because we want to decide the whole process of how we are manufacturing that blade. So it is a like 5-layer composite blade, but we are coming to the details later. So as you can see in this figure, we have the calculations for like the geometry of the blade. So like there are 31 stations across the whole blade, and starting from station 1 up to station 31, we have all the cross sections and all the calculations are done by Advaya about how the blade geometry and the like airfoil section shape and the tilt should be. So that part is already decided. We have to execute on how the manufacturing process will be. So in this you can see that station 1 is a little bit different, rest all sections are same. So in our PPT you will see that there are two sections on majorly like how we are making the blade. So one part will focus on these sections which are like lengthy in nature but are simple. The geometry is large but the process is relatively simple compared to the section between station 1 and 2. In between station 1 and 2 the number of components is higher, but basically the geometry is relatively smaller. It's only 50 centimeters across. So if you will see here, you will see the major parameters for the blade. So this will include the length, which is like around 3.2 meters, and stations 31 as I said, and material is FRP. So FRP is fiber reinforced polymer. So actually it is more accurately GFRP, which is glass fiber reinforced polymers. So these are essentially a class of composites, and in composites we are using composites because they have a higher weight to strength ratio. So that is very important for us, and that is why we are using composites.
Strength to weight ratio.
Strength to weight ratio. So we are using that, and usko FRP bolte hain, we are using 5-layer FRP for one side. But like that also was done, calculations were done on that, but we will not get into it, how the 5-layer process was designed. Uske baad the thickness of the blade, essentially the cross section of the blade. So if this is the aerofoil shape, so the cross section of the blade will have a thickness of 4 mm.
So it's the skin thickness.
Skin thickness of the blade will be 4 mm. Actually, ma'am, this was updated, right? It will be 5.
It will be 5.
Yeah. So this is like a older version of it, but this will be around 5 mm. Because each layer is approximately 1 mm, and it will be actually a little more than that because there is a tape in between. We'll come to that later. So so inside of the blade, as I said, this is 5 mm. So what about the internal structure? Apart from the skin. So internally, according to the calculations, hollow blade will be made, which is sufficient because of the size of the blade. The size of the blade is approximately 3 meters, and in this scale we need not put some stiffness. So in large scale blades you have some support material in between. So if you take like very large blades which are from GE etc., they will have some wooden stiffness in between to like ensure that it's not buckling inside, like not compressing inside. The shape is intact. But for our scale it's not required, so we are not using that. And next is aerofoil between so these are the station 2 say 31 tak we have the aerofoil sections, and like station 1 is for structural attachment to the hub.
And then Kishore, you have taken the printouts of all the stations.
Yes. Yeah.
So you know how each one looks like.
Yes.
And the cord length is changing, the thickness, the physical thickness is changing, and the twist angle is changing. Right.
So the scale is reducing from station 2 to station 31, and the tilt angle is also changing. And apart from that, so next we are coming, this is just a calculation on, like we were just discussing this, the velocity triangle and how the aerofoil shape calculations were done and how the aerofoil shape was decided. For our purposes, we will not get into the details of it, but this is how it was done. So we'll come to the major part of it. So I will tell you a little bit on the blade terminologies. It's not included here, but I'll write it down on the board. What are the main terminologies we have to be very sure of when we are discussing the blade? So one part is pressure side and suction side. So the aerofoil shape, as you can see, is not uniform. So if you will see here, the top part of the blade is having a larger, like a smaller radius of curvature, and the bottom side is a flat. So it has a larger radius of curvature. So as you can see, the upper side is labeled suction side, and the lower is labeled pressure side. So whenever we say we are like referring to that, we have to keep in mind what part of the blade we are referring to. So these are some of the like list of things that I will note down, which are like will be used completely throughout the presentation. So we need to be very sure about what we are referring to in the geometry of the blade. So next part is actually a little bit on the like blade die as well. So if you can see here, the die of the blade is somewhat like this. So the die of the blade is in two parts. Okay. So so die of the blade is in two parts, and we have the top part and the bottom part, and as you can see, like the top and bottom are referred as pressure and section as the shape of the part it is made of. Okay. And for the next part, what I was referring to is the like these are the two parts of the blade. So uske liye when we say the pressure side of the blade die, then we meant the top side or the bottom side, whatever is the case. So that is what like the terminology is meaning. And apart from that, the nose and the tail. So this part of the like aerofoil section is shaped like a nose, and this is called the tail. So whenever we say even in the die, so if we draw a like section of the die, like this side maybe will be the tail side, and this side will be nose. So this will be true for both of the like parts of the die. So this will be also be tail, and this will be tail, and this will also be the nose. So the tail parts will come together and the nose parts will come together. Actually, it should be of the opposite, because we'll first start with the like join towards the nose, and the tail will be joining later. So we'll just reversing that. So this is the like this whole section can be referred to as the tail side, right? So whenever we like mention that, we have to keep in mind what we are referring to. And next, apart from that, we go to the क्या बोलते हैं एक और चीज बची हुई थी, tail side, nose side हो गया, हाँ, the root and the stem, root and the tail. So the bottom part of the blade, as we are referring in the last figure, we have the bottom of like the blade which is like larger in size and the smaller in size in the station 31. So this is called the tip of the blade, and this will be called the root of the blade. So this will be true for both the dies. Like the root of the blade will be the section 1, and the tip of the blade will be towards the bottom, and which will be section 31, station 31. Yeah. So now we are coming to the like I told you that we are using GFRP, but what exactly is GFRP and what materials are used in that? We are coming to that right now. So I have referred to this like earlier, but we are using a 5-layer composite. So by 5-layer, we mean that like in the skin, one skin of the blade, there are 5 layers, and each layer is approximately 1 mm. Okay, so this we are referring to 5 mm. That is actually, if I make a larger view of it, this will be consisting of 5 layers. So I'll add a little bit in the middle, whatever is left. But imagine that these are 5 layers of the skin. So we are basically using 2 types of materials for this. So one is called chalk stand mat. In short, it's called CSM, and other is woven roving mat. So these are the 2 types of materials that we are using. And in the figure, I'll show you that these are used in alternate. So 2 materials, and we are stacking them alternately. So on the bottom, you will see. So on the bottom you will see that we are using just a second.
Okay, let me tell you here, CSM and woven mat both are GFRP.
Yeah, exactly.
But their weaving styles are different.
Yeah, I'll come to the style of it. So you can imagine a little bit on the name of it. So this is called chalk strand mat, right? So in this we have random orientation of strands of the fibers. So if you will see on the top view of a blade, it will be like randomly there will be some chalk strands which will be included in the mat, and which will be arranged randomly. So this surrounds like the directionalness nature of the all the material properties will be randomized because of that. That is the major reason it is like that. And the woven room mat is actually very uniform. You will see that it is like actually woven into a grid. You can see those are where there in the ship making the die making lab which was there before beside the MCL, you will see that the samples are available there. So like these are the two different like types of materials that we have, and in this as well, like the reason of choosing like CSM and WRM and how we are basically like arranging them, how the alternate nature is used, that the whole testing was done by Rishikesh. Rishikesh was doing the that's the material testing of all the types of blade. So we can use 4 layer, we can use 3 this, 2 that, and every configuration was tested, and material testing was done. The blades were casted, the sections were casted, and like UTM was used, and there were 3 tests done. Like we will not get into the details of that, but testing was done to determine 5 layers are being used in the blade fabrication. So,
and we found that when only CSM was being used, 2 layer CSM, we got some strength, but the moment we added one woven mat, the strength like doubled or tripled or became 5 times. Woven mats, 1 layer dalo, you get a very big jump in the strength actually. Yeah.
So like I think like this will be the order rate. CSM will be used thrice, and 2 times we will be using the woven mat.
Yes.
So CSM से start करेंगे, we will go like this. So alternate जाएंगे C. This will be the order. So chop strand mat will be starting with, and then 2 layers of WR, and बाकी rest 3 will be this. So this is the order of the like fabrication. So if you imagine, so if you have to make the let's say we are creating just a single cross section of the die. So like let's say we have a very simple crude die that we have, and let's say we are making the we are casting the FRP. So in that first I'll put CSM, and then I'll put the next layers in this, and the other section of the blade which is there, which will be placed beside it, it will be a little bit shallower. It will be the similar in shape, but it will be shallower. So here we will cast it, here we will cast it, and we'll get into details of course, but this is the order in which the mats will be placed. Okay, and of course these mats are not just placed; these have to be fused together in the end. So we use 2 parts. Like one is the resin, and another is hardener. So resin essentially is the part of the compound which is giving you the strength, and hardener essentially accelerates the process of hardening of those epoxy or whatever the glues that is adhesive that is being used to fuse all these mats together. So when you actually place it and then you mix the hardener, it will start hardening at the time that we want in the fabrication process. So if you you can use multiple hardener types which may be faster or slower according to the requirement. So
and this process is called curing,
yeah.
And it takes quite a few days depending on the temperature and the humidity. Very often, very professionally, it is done in a controlled environment.
Yes.
So the bottle making is done in a controlled environment, closed indoors, where temperature and humidity is properly maintained.
Yeah.
But here we are not doing that, so we'll have to give a little more time for the curing to be complete. A few more buffer days than we should be given.
On the large scale, like turbines, as ma'am was saying, the control environment is used, and apart from that, even when suppose this is casted, over this a bag of plastic is placed, and it is vacuum sealed, so that the adhesion also is very proper, and you can actually stick to the die surface as well very easily. So these are the advanced techniques that are used in actual industrial fabrication. But right now we are creating a very small scale, so we are not using that. And as ma'am said, because of that we have to give a little bit of leverage on the time that we have for the curing process, so that the curing occurs as required. So in industrial we need faster processing. That is why all these methods are added. So here all the properties of all the composite are shown here. So the name and the thickness of each layer. So a total actually 4.59. So these are 5 layers of composite. So I am saying 5 mm because there will be some additions which you will see further in this PPT, that there are some additional layers which are placed which increases the thickness. So the density of the composite, the elastic modulus, and the yield stress. All these are calculated by Rishikesh on the UTM and other machines that were
not calculated, measured. Calculation means you have to do using formula.
Yeah.
It's measured with the UTM.
It's empirically measured by the machines. Yeah. So these are others certain parameters for the blade material. So for the blade, I think these are for the blade material. So root of the dimensions of the blade are little bit shown here. The root chord of the blade, tip chord of the blade. So the station size are reducing. That's what is mentioned. These are just parameters for the geometry of the blade. So I told you about the this is the shape representation of the actual mats. So this is a chop strand mat and the woven rubber mat. Okay, and this is the resin and the hardener. Okay, so I'll come to the geometry of the whole blade. But first, I'll tell you what wooden block and wooden block and the stem are. So, as you know that there are three blades being constructed, which will be going in 120 degrees with the hub. So, like hub will be like this, and the blade will be perpendicular to this. So, to attach this blade to this, we are not directly bolting it to the FRP. We are using a stem. So that stem will be shaped like this. We'll make it a little larger. So that stem will be shaped like this. So this part of the stem, I'm calling this a stem. This is just a terminology used in the blade. This is also included in the terminology for the blade. So this part of the stem will be encasted inside the blade. So this will be casted with the blade in this process that we are referring to. It will be further shown how it is done. But this will be casted with the blade, and this part will come and bolt here. So if I show it here, this will be the process by which it is bolted. So this will line up with this. This is the process that it will happen. So this part will go to the hub. This is the hub, and this part will be casted with the blade. So if you see the blade, there will be two stems like this. If I see a very crude cross section of it, it will have two parts of it like this.
So a pair of stems, one on the suction side, one on the pressure side.
Yeah, exactly. So this will be the blade in the root side. You will see some stems extrusion where the hub will sit between this. Okay, so this will be on three sides. This will be done. So this has to be casted with the blade, and this process also will be included in how we are doing this. So this is just again an introduction to what we further if I refer to the stem or the block. This has to be ensured that how we are actually what are we referring to. So in this we have the block as well. So the block is added at the root of the blade. So the root of the blade we saw in the earlier figure is a very rectangular section. So in that rectangular section at station 1, we have some space to place this block, which is essentially made to give structural strength on the blade to the blade. So if we see the aerodynamic, as we were discussing the aerodynamics of the blade, the majority of the lift is generated on the tip side of the blade, and the root part generally experiences most amount of stresses. So to give it structural strength, we are adding a block at the root of the blade. So this block which was shown in the figure, it will be placed like this. Will be placed in the root of the blade, and this again will be casted with the blade, so that the transfer of forces is not passing through any joints. So when we cast this with the blade, we ensure that all the parts are secured firmly with the blade. So this and the two stems both will be casted in the root of the blade. So when I say that station 1 and 2 have more components, this is what I mean by it. There are blocks, there are stems. There is one block and two stems along with the layers of the FRP. So this has to be incorporated in the manufacturing process. That is why station 1 and 2 was a little bit tricky and complicated. Along with that, we have some holes here. This is of course for mounting, let's say the blade to the hub. But apart from that, we have six bolts here, which will basically pass through this. This apart from the casting, we are giving mechanical strength apart from the casting. So this is just bolts will be screwed, and this will be screwed through this. So the complexity in the root of the blade also rises by the alignment of these holes. For all the sections, all the parts, we have to align the holes, and that is what we'll see how we are going to do that. So next, this is the okay. So right now at this stage in the MCL, you will see the die of the blade is ready. So basically, I think there is a very big mistake, a big shortcoming on my part, that I have not mentioned this process. This hand layout technique of making FRPs. So FRPs can be also manufactured with machines and stuff, but we are using a hand layout technique which is on the scale. So in the hand layout technique, of course you have the die, which the casting is made. So this die is already made in the lab. So we have the first making of the die is essentially I'll give you a very short process. So suppose I want to create a shape, or I want to create, let's say, a shape like this, and I want to create a casting for it, a die for it. So first I will create this shape using some other material. It doesn't matter what material I want. I would just create the geometry of this. Then I will create a die around it. So in our case, it was made of like wooden stations were used. So the whole blade was constructed. This is what you can see in the figure. So this station actually has like a rod inside it. A metallic rod is there, and all the stations are included. So 31 stations were made of wood, and they were all placed here. Like on each station, there was a wooden station that was placed, and then the putty and extra material was used. FRP was also used to basically create this shape. So this geometry was made. After this geometry is made, we use this geometry to create the die. Alright. So this like let's say I use this and create a 2-part die around it. So this is also made of FRP. So if you go down there, this is also made of FRP. I think this is also 5 layers. Yeah. This is also 5 layers which is created, and this die.
No,
is
it was 2 or 3 layers, and therefore it was not very strong, and that's why the wooden stiffeners were used. And the wooden stiffeners are also cast. 2 layers, फिर wood, फिर एक layer.
ताकि वो भी fix हो जाए. Yeah. So like yeah, that is like more on the die manufacturing, which will skip through because it is already done. So this is then you take out the mold, and then you have the like if you see, then you have the 2 parts of the die you have ready. So this is how you will make the die, and that is already done by now. So what you see there in the presentation slide is the pattern that was made. So what I mentioned here earlier, that we create the actual shape. This is called the pattern of the part that you are producing. So this is the pattern. This is the die. Okay. So this is the pattern that was created, and as I showed you the process, there was a metallic rod all throughout the length of the blade, and the stations were wooden stations were kept, and the geometry was made, and there were other things that were used, putty, etc. And then finally a gel coat is put. So you can see this is very shiny. So after that a gel coat is put so that the surface is not contaminated. And the die that was shown, this is the die that you can see. So I think you both are aware of how the die looks, etc. But you can see that station 0 or the root is here, station 1 is here, and tip of the blade, which is station 31 is here. And these tabs that you see are for the alignment of the die. When you put the die together, the die should align up. So yeah, this is the progress till now.
Yes. Yeah. Continue.
Yeah, so you can see what the die is. So right now, this is the process we are at. Now we want to start manufacturing the blades. So that is essentially what we are discussing, and how the process will be. Yeah. So I think now we are coming to the station. Like I have divided the PPT. We have divided the PPT in 2 parts, which will be station number 2 to 31. How the blade fabrication process is done. And for 1 and 2, as there are more components, we'll discuss it a little bit later, and we'll put in a lot more details on how we are doing that. Okay, so all the processes that were discussed here are basically from station number 2 to 31, and how we are basically going to cast the blade. Alright, so we'll only show here only one part of the die. So as it is a 2-part die, I will showing you only one part of the die, and the rest, the second one will be parallelly going on the same scale. Actually, yeah, I wanted to refer to you, ma'am. This actually the slide is a little bit outdated, so the staggering etc. is not here.
Oh,
so
yes.
do you want me to draw it there?
Okay. Yes.
So yeah, I'll actually draw it there, which will be a little bit better idea.
आप बिल्कुल सही टाइम पे आए हो. अब कास्टिंग का ये प्रोसेस चालू होगा जो आप सुबह कर चुके हो. आप वो वीडियो सबको फॉरवर्ड कर दो. आप अभी ग्रुप में भी आ गए हो ना? हाँ, ग्रुप में डाल दीजिए.
So let's imagine that this is the die surface. This is a little bit क्या बोलते हैं inaccurate because I'm not starting from the nose. Actually, the chord length is the thing which is dividing the die. So it will actually start, the nose part will be actually here, which will be starting the shape or geometry of this part of the die. So we'll start with the fabrication process. So first, the thing is, I'll give you a little bit bigger picture. The problem with this whole manufacturing process, or the fiasco which is created in why we are going into the depth of it, is because we want to create two parts are created. Now we want to join them, right? So how will you join them? You can use adhesive, you can use tape or whatever, but the external surface should be pristinely exactly how the die is, because aerodynamics and etc. depends on the surface finish of the blade, so that can't be tampered with. So the idea that was created is that we will use two parts of the whole blade. So how will I go about it? I will show you with a very crude example. So let's say we have a two-part die, as we are like normally using, and we are actually going to create two parts of the blade. And how we are going to do that, I will show you right now.
This was just the original idea.
Yeah,
He cracked
we
it.
brainstormed this together with Prasunjana and Gautamda, etc. sitting together. But basic idea is that we are going to create like two parts, exactly how I will show you. So for example, let's say I will go into the details step by step later.
आपका 5 मिनट में क्लास शुरू होने वाला है, जल्दी करो.
Yeah. So imagine that like I'll go into the details step by step later, but I'll give you a very brief idea right now. So what we'll do is we'll create, let's say, a single part, like let's say 5 layers में से I cast 2 layers, alright? Then I'll also cast the rest of it here, like the 3 layers. Let's say we cast the first 2 layers of the casting. That out of this, let's say these 2 are casted right now. Okay. Next, let them cure. So what happens is after they cure, so what happens? I put some mold release here or some kind of agent which will like let me release it later, but we will get the details later. So I put some material here which will allow me to separate the two parts, the two part and the next 3 parts. So what will happen is now we have created the first 2 layers, and I have like a very crude layer which is placed just to hold this placeholder. But the next 3 layers are placed there. You will get why we are doing this in a just tiny bit. So we are creating basically the first 2 layers. We are putting some material which will help us separate it later, and we are putting the next 3 layers. This is clear? Then we go and take out this 3 layers.
हाँ, तो अभी मेंशन कर दो शेल किसे कहते हैं, कोर किसे कहते हैं.
So this part which is being removed, as it is inside, it is in the core of the blade, which is not being seen. This is called the core of the blade. And the outer part which is covering this whole thing, like the 2 layers, these are called the shell. This is again in the terminology of the blade. So these 2 layers, the first 2 layers will be referred to as shell.
जो आपने आज सुबह कास्ट किया.
And this will be referred to as core. And we'll go into the details later on how each step-by-step layer is being casted. But the basic process is that we'll take these 2 out. So imagine that these 3 layers and these 3 layers are taken out and they are placed together. And we have a tape that we use, which will basically a double-sided tape. So imagine that I have a tape which is wrapped around this. So there is a cut here and there is a cut here, of course, but the tape goes around completely. Okay, so this is the tape. Now imagine you have a material. Let's say I have it here, but so this is the die. This is the outside is the die, and I will take out the other sections in between. So there are the core and the shell. I'll take them out. So this is the shell of the blade and this is the core. So the shell is not coming out, so I'll keep it in, and I will use the 2 cores to take them out. I'll just explain the process on hand. So this is the core of the blade. So now this is the core which has been taken out after the curing. So all the curing is done. Now I will wrap the tape around this. So the tape is double sided. So it will first of course align this, but there will be the outside side which is also sticky, right? So what I will do, I will take this and I'll then put it over, let's say, this side. So this is the tape, and now outside part is also sticky because the tape is double sided, right? So I place it here. So it will stick to this. And then I will take the second part which also has the shell of the second part, I'll place it over this. So in essence what will happen is it will create an internal joint. So if I get the marker, yeah. So this will now be placed over this will be taken up and this will be placed, let's say, here. So I have the die and 2 layers of the shell that were casted before this. I should be using a different color, but right now I think you get the idea. So this is the top die and the 2 layers of the shell that were there. This looks a little bit like too much space is there between the layers, but it will be of course combined together. So then you can imagine that this joining process ensures that the outside layers are never touched and the whole blades come together. So this is essentially the process that is used throughout the blade, and we try to use it in station 1 and 2, but there are complications, we will come to that. But from station 2 to 31, wherever there is an aerofoil, we are using this method. Okay, and now what we are going to present to you is essentially the 5 layers, how are they casted? Like what is the process of casting the 5 layers? Alright, so here we will start with one part of the die will be explained, other part is exactly the same, there is no difference there. So first let's say we start with the chop stand mat. So first layer of chop stand mat is placed, it is casted over this. Yeah. So then the second layer is also casted. There is no problem until this. The problem arises after this. So one more problem which I haven't mentioned yet, in theory this aerofoil shape goes to 0. The tail part of it, nose has some thickness, but the tail part of it actually goes to 0. But in practice, of course, it won't go to 0 because the structural strength will not be there. So in our case, we have measured the template and etc. everything. The tail end of the blade is 5 mm. Alright. So the problem arises because each skin is 5 mm. When we come to the end, we get 10 mm, which will not be fitting inside the die, right? So we want to reduce that. For the tail part, we need total 5 mm. So what we have planned to do, we have planned that the core part of the blade, which is having 3 layers, which will not extend to till the end of the blade. So only the core will be having a little bit shorter length till the tail on the tail side. Nose side there is no problem because thickness is sufficient. Getting the point? So before I go further, this was just an explanation, but I'll tell you the whole casting process anyway. So next we want to separate this core later on. So we'll place something in the middle. This layer which is placed, which I am referring to as placeholder layer, is not only placeholding like the material to release this later, but the tape also has some thickness. The tape that is used here has also some thickness. So that thickness and the layer that we are placing right now should have the approximately same thickness in mm scale, so that when we place it, there should be no foul in the geometry of the die and etc. So now we are placing the placeholder layer. This is a layer which will later on help us release the core and the die separately. Okay, so now after this, I think we need not push it till the end. We'll put it only till where the core is there. After this, we are going to cast the 3 layers of the core. So again, that is not something which is very like unique something about it. But one thing that is unique is that each section will be placed. There will be some difference in the length of the shell and the core. This distance is something which we are determining right now, and it is not exactly like finalized, but it will be somewhere in the ballpark range of 3 centimeters to 4 centimeters. That was calculated by Rankishore, and each station was referred to, so that we can calculate how much thickness we want to, how much distance from the tail we want to leave, so that we get the geometry of the blade coincides with what our design is.
You can maybe show the staggering here.
Yeah. So the staggering is actually shown well in this model. I'll only refer to like one part of the, like you can see this here. So the nose part is completely aligning with the this, but if you see, I will space them a little bit so that you can see better. So you will see that the tail end has a staggering. So if you see if you combine them together, then to here also you can see that how the thickness of the blade is just pushing it together. So if I had been using this, then this tail will not match. The tail thickness will not match. That is the reason the complexity in the fabrication process is arising, and this is how we are trying to mitigate it. So now let's say imagine the 3 layers of the core are placed. Okay, so 3 layers are placed, and then later on the process, as I have been mentioning, this will be removed, and I will be joining I will be drawing these 3 layers together from now on. So I will be drawing the core together. So let's say this is the core which has been taken out of the blade right now. So I'll just make it up. But yeah, so this is the core, and the second part of the core is also, the second part of the die is also making the same replica. So we have the core of the 2 parts of the die. I hope this is clear until now. So like I will also tell you a little bit about the timeline. So on the casting process, these two layers of the shell will be casted first and it will be left for curing, and that curing process will take approximately 3 to 4 days for the shell, and after that we'll put the layer the adhesive layer.
Curing is actually an exothermic process.
Yes.
So it happens faster in winter.
Yeah. Yes. So yeah, exactly. So the resin and hardener like it's an exothermic reaction, so it emits some heat and like temperature difference is larger in winter, so it's easier and it's faster basically. So the shell will take approximately 3-4 days for curing. Then the core will be casted, and and the placeholder layer will be placed. That doesn't require any time, but this will also take, curing will take 3 to 4 days. So approximately a week has passed, and the two parts of the die, all the material has been casted.
Casting itself is very fast. You saw like within half an hour it was done.
Yeah.
वो छोटा सा बड़ा सा करने में चलो 1 घंटे में हो जाएगा. बहुत सारे और लोग रहेंगे. More number of people will be there. So 3.3.5 meters will be done. मतलब 3.24 meters will be done.
So even though the geometry of the blade is large, it is all being in one go. So there will be large number of people on deck, and it will be done. The casting process will only take like only 2 hours at max for the whole blade.
And it has to be done in one go.
Yeah.
Otherwise there won't be structural continuity.
Yes.
The curing has to happen at the same time.
Yes. So the resining and the hardener, everything should gel together. For that we need more like faster process for it. So yeah. So right now this 1 week has passed and the two things are cured. So all the material is now ready. We have to tape it together, and the process we have done, we have to do that now. So now the core of the two, these two are the core of course. So the core of the two dies is lifted up, and this layer is also peeled off. But right now we'll focus on the taping part. So here we have separation, and here we have separation. So right now the tape that is being used, that also requires primering of the surface. So what essentially means is the surfaces that are being adhered. So for example, I want to adhere these two surfaces. Like let's say I want to adhere these two surfaces. So the surface roughness and everything should match in a way that the tape will be between this, right? So the tape has to adhere to both of the layers properly to ensure that we use primering. So primering is essentially a process in which you prepare the surface for adhesion. So that is also used in many like any adhesion process you will require primering, like most probably. So that is essentially wiping the surface clean with alcohol first, and there is a primer which is a chemical which is used, which essentially cleans everything and prepares the surface for adhesion. So that is also done by the tape manufacturer itself, or the tape manufacturer gives you the primer as well. So we are using primer 590.
594.
594. So we are using primer 594 for the preparing of the surfaces. So primer will be applied over here. First, I'm not drawing that because it's not having any thickness. It's just a liquid that is applied. Okay. So that is applied. So primering is done, and after that the tape has to be applied. So we have decided that the tape will start at the middle of the blade, because here we already have some ends. So we don't want to start and end the tape at a point where the separation is already occurring. So we'll start, let's say, from the middle of the blade, and we'll go around. And this is how the tape will end. So the tape will start at the middle and it will go around the blade. So it will completely encapsulate the blade. And we will ensure that as it is a double-sided blade, we will only remove the protective tape from one side, and it will be cast. It will be taped on the core of the blade. So right now the core is ready and it is taped. Now we need to ensure. Now next we need to adhere it to one side of the base. So what we'll do, let's say I'll remove everything here. This is already removed, and this placeholder layer is now removed. This will be replaced by the tape thickness. Tape thickness is also 1.1 mm. So the tape's thickness is 1.1 mm. Right, so that is also taking, that is the approximately 1 mm adhesive layer, the placeholder layer that we have, that is what we are using. So now this will be placed over here. But before that, again, this is the same tape that is being used. So the bottom surface also needs primering. So that will be primered next, and it will be first cleaned with alcohol, etc. And then the primer coating will be applied here. And after that, this whole surface will be placed over this. And that will essentially ensure that the core and the tape are here.
The integrated core has to be placed very carefully on the bottom die with the inner surface of the shell primered.
Yes. So inner surface of the shell is primed, and before removing, of course, you should remove the tape. We will remove the tape on the outer side of the blade, so that is 6 to. So right now, you will see that there will be some geometric, like there will not be much continuity at this stage as well. So here you will see that the thickness might not be completely covering, like it will be just a drop, right? If I zoom in a little bit, it will start like this and it will be a drop because of the, and this will be the shell, let's say, right? So this part when it comes over here, so it will not be completely, like there will be some part, as you can see here as well, there will be a little bit of like air gap in middle as well. Like when you like touch this, there is some amount of gap that is placed here, so that also needs to be filled. We can't like leave it completely. So there will be another material which will be the sealant which will be used. So
adhesive. Adhesive. We have an adhesive.
No, we are not using the sealant. Sealant was a little bit
because adhesive provides structural strength. Sealant doesn't provide any structural.
Sealant will only crease the surfaces. Like if there is a crease, it will finish the surface. Sealant will just seal it, of course. But adhesive will basically adhere.
And remember the nose joint and the tail joint, both of them are occurring on the neutral axis of the bending of the blades. And at the neutral axis, you have the maximum shear stresses. Bending stresses are 0 at the neutral axis, but shear stresses are maximum at the neutral axis. So you not only need the tape, you also need the adhesive at the nose and the tail joints for increased strength.
Yes. So apart from the gap here as well, both parts of the blade. So if this is the, like longitudinally, this will be the section which will be completely covered with adhesive, and that was approximately
1 centimeter.
1 centimeter, I think, like we have decided that 1 centimeter will be more than enough to spread the material approximately. But here a little bit larger may be used because we want to cover the whole tail. So here next the adhesive will be put. And now the other part of the die, which will be placed above this, that will be primer, and it will be put over this part. And in that, basically, we only need to primer the other part of the die completely. So I think that will also require a very fast process because the whole blade has to be primed and completely put up on this part of the die. So right now we are coming at very close to the end of the casting process. First, there will be some complications below it which will go parallelly. So the part we are not discussing right now, station 1 and 2, that will actually go parallelly to all the process that we are describing right now. But we'll come to the details on what are the complications there later on.
Are you sure you want to miss the class?
Yeah, I think you'll be fine.
Is it okay?
Yeah.
All right. आप लोगों का class है? Okay, fine. Sorry.
So